Okay, hi everyone. I'm Michael Wanli Qian. He is Jesse Chengfeng Gao. We are previously master students at University of Chicago XLab. Now I'm in USC and
I'm in Northwestern.
as first year PhD students. Today we're going to present our work, Shape It, exploring text-to-shape display for generative shape-changing behaviors with LLM. Before we start, we'd like to thank our collaborators Anup Sathya, Ryo Suzuki, and Ken Nakagaki, which I think all of them is in the audience, for their great support.
Okay, so with recent mind-blowing advancements in generative AI, text can be transformed into various outputs, such as text-to-image, text-to-video, and text-to-3D, which this one can help designers create 3D assets with ease. But there are more LM applications in the market. In our work, we explore text-to-shape display, using text instructions to create dynamic shape changing on the shape display. So what is shape display? Shape display is a well-explored topic in HCI domain, not only because it can render physical and dynamic shape information, but also enable tangible interaction for users. We have seen so many exciting demos that shown in prior research. Our work is motivated by the question, how can people just create dynamic shape-changing behaviors on demand, only by asking them what to do? Let's imagine a scenario making a wave effect on a shape display. So previously, you can have a predefined GUI, which allows you to define the wave animation before rendering it on the shape display. Also, if you have the camera set up, you can map your gesture movement to achieve the wave effect. What's more, you can also sync your tangible touch input to visualize the wave effect on the shape display. But what if, just by asking the shape display, create a wave pulse pattern that moves across the shape display? Yeah, this is an actual participant creation in when using our system. So how did we enable such transformation? We use text-to-code approach. By employing LLMs to generate the executable codes, which then can drive the shape display, ShapeIt enables user to quickly generate the dynamic shape-changing behaviors by simply ask for it. We are not the first one utilizing code generation in the HCI domain, as we can see some successful examples from generating code for learning programming to creating code exploration, as well as the Jesse's moving the robot. With this idea, we did a formative study to understand the challenge. First, it is quite important to understand how do people describe shape-changing behaviors through text. We conducted a cross-sourcing study with 400 participants, asking them to provide text instructions based on the prior shape display work. And with more than 300 user-generated prompts, we found 3 elements that's necessary. They are primitive. Oh, no. Okay, they are primitive, the base shape or the pattern on the shape display, and animation, which can be applied to the base primitive, and the interaction, the controls that the user want to interact with the primitive to achieve the shape-changing behaviors. Another question is, only through text input, how should we design the user interface? With an early prototype with ChatGPT-4 and the future prompting, we conducted a pilot study with 10 participants to gain insights. We learned that just a text input box is not enough. More elements are needed for the better experience. First, while waiting for the generated result, we need to let the user know what's going on by displaying the breakdown tasks. Second, the primitive animation and interaction modules need to be module designed for flexible control, as well as the conversational history need to be enabled for future exploration. And lastly, the slider UIs will allow users to fine-tune the generative shape-changing behavior in real time. To this end, let's have a walkthrough.
So yeah, I know this is a lot of information, and many of you who probably doesn't know ShapeIt before is having a hard time processing all of these information. So perhaps the easiest way, and in the spirit of UIST, we're gonna provide you a live demo. So what if I want to create a dynamic heart shape with a pumping animation? I can just simply type in create a pumping heart shape. Okay, this is gonna send the commands to AI, and while we're waiting, let me show you something. We're actually live from Chicago. So this is the actual hardware setup in our lab. Yeah. Okay, so here is the ShapeIt has already given us a primitive and an animation, which is exactly what I wanted, because I sort of indicated this pumping animation. And it is sort of doing this by simulating, but it's simulating pumping animation by sort of manipulating the heart scale parameter. And I can also manipulate by using sliders. And if I want to adjust height, I can do that as well. And I also wanted to follow up with another command. So I wanted to author interactions. I can say, I want to control the left and right movement with 2 buttons. So make sure I articulate the intent of wanting to interact with it. So yeah, it will give me an interaction component. Yeah, it will give me an interaction component which will create buttons on using the pins on the shape display. Let's hope it not fail. 3, 2, 1. All right, couple more seconds. Okay, there we go. Okay, nice. All right. So I'm going to ask our helper Chi in the lab to help me press the button. Okay. So Chi, could you please press the left button? Okay. Could you press the right one? Oh. Okay. Seems like the buttons is having some issues. Let me adjust it real quick. I can also simulate the button press in the virtual setting. So if I can press this, okay, it's why is it not moving? Okay, it's maybe a hardware problem. That button is getting stuck on the hardware and it's not properly synced. So okay, we'll work on that. Thank you. So just to reveal, like in the back stage of things, so how we did this implementation. So for our system architecture, when user first type in the text input, our prompt helper agent, which is built with GPT-4 Turbo, segment user input into primitive animation and interaction segments, as well as extract the relevant parameters, which then compile the code instructions based on these results. And the code instructions then flows through the respective script generators, which is built by GPT 3.5 Turbo with rule-based prompting and retrieval augmented generation. And this gives us the respective JavaScript codes, which is then sent to the front end and load and compile in runtime. Then the parameters will be displayed as sliders for user to fine-tune the results. And in our user study with 10 novice participants, we explored ways of authoring shape, motion, and interaction. So let's see, for example, user created some cool primitives such as fireworks and a circle circling around another, sort of like a solar system, and pushing the button to rotate the cube even. And during our user study, we found some surprising results that we previously thought that would be hard for our system. Specifically, real-life movie conceptual creations, such as the mountains in the movie Dune, and complex animations like making the circle to chase the cubes. And by the way, users actually using the sliders to manipulate the cube. We also observed some failure cases, such as long car, bird head with beak, and hand shapes. The common pattern among these failures is that shapes associated with complex semantic concepts, which are difficult to represent mathematically, tend to result in outcomes that are hard to visualize intuitively. ShapeIt's ability to understand user intent and generate tangible shapes, animations, and interactions in real time unlock exciting new applications. For instance, adaptive tabletop furniture like bottle holder and delivers the bottle with a push of a button. And also gaming and storytelling by AI dynamically creates scenes and mechanisms in real time based on the narrative, such as the Dungeons and Dragon Masters can generate traps based on player actions. And a dynamic scene where a character is peacefully meditating on an island until a rising tide brings it to its demise. So in ShapeIt, we used LLMs to understand human intent from text inputs, enabling real-time authoring of shape display. Alternatively, our poster paper work, we explore text-to-mesh method using Clip, where we enable user to use speech to create 3D mesh, which can be rendered in real time on shape display. We also integrated speech, tangible, and gesture processing pipeline to cater more user interactions. We envision the development of future AI models, such as 3D-aware spatial intelligence models or large world models, as inspired by Dr. Fei-Fei Li and her World Lab, which would allow us to capture nuanced human intent expressed in 3D context that leads to, for example, manipulation-aware 3D adaptation. This points to an exciting future envisioned in the concepts like Claytronics and Perfect Red, where tangible user interfaces can adapt and respond seamlessly to a wide range of user interactions. In closing, I encourage STI researchers to explore the potential of generative AI for creating shape-changing interfaces that can understand and more accurately adapt to human intent in real time. And with that said, we would like to thank again for our collaborators, as well as all of the Axe Lab members for the informed assembly, as well as Chi for remotely collaborating with us. Thanks.
Thanks, ShapeIt. And I think, and also for the live demo, it's really cool. And I think we have time for one question. If you are interested, yeah, you can line up over there. Yeah. If not, then yeah, we can, yeah.
I'm Zed from University of Pennsylvania. That's a very exciting interface and really dynamics. But I'm wondering, like, whether in the future you are also considering to have some more fine-grained control, like the force feedback control, to rendering like the stiffness or the softness of the material and those kind of stuff.
Yes, so that's a certainly exciting direction. So thank you for your comment. And actually, our advisor Ken Nakagaki has a previous work called Materiable, which explores how to rendering how would liquid respond to like the external user inputs. So in our case, it would be similarly interesting if we can making AI to author the material properties of things by changing the configuration of linear actuators.
Can I ask another question?
Yes.
Like, do you
Yes,
think
please.
like it will be better if we like shrink the area of each pixel, just make the resolution higher? Will that like dramatically increase the human interaction experience and something like that? Have you experimented with that before?
Yes. So because this hardware is like takes a lot of effort to build. So
it's
we
like
certainly thought
multi-channel.
about like having a much more higher resolution shape display. Actually, we have observed like previous works such as Shapeshift, which uses a fine grain pins. So yeah, we definitely thought about that, and I think for the future it can happen. Yeah.
Thanks a lot.
Thanks.
Thank you. Thank you for the